In the world of software, it feels like everything is moving at a million miles an hour. There's always a new framework, a new language, a new paradigm just around the corner. But here's the funny thing. Some of the absolute best, most practical advice for building amazing software today actually comes from essays written decades ago. So let's dive into some timeless wisdom that, believe it or not, still shapes the very best of modern engineering.
It really makes you wonder, right? In an industry that is completely obsessed with the next big thing, why is looking backwards so incredibly important? Well, it's because the tools, they always change. But the fundamental problems, they don't. Things like managing complexity, building for real value, and, just working with other human beings. Those challenges are absolutely timeless.
So, here's how we're going to break this down. First, we're going to take the high-level architect's view, focusing on strategy. Then we'll zoom right into the nitty-gritty, the builder's craft of writing solid code. And finally, we'll pull back out to look at the professional's mindset, which is all about connecting our work to people and actual business value.
All right, first up, the big picture. Before you even write a single line of code, some of the most critical decisions have already been made. And the core theme here, the big idea, fight complexity at every single turn.
A really brilliant way to think about this is Dan McKinley's concept of innovation tokens. Just imagine that every project you start gives you just three of these tokens. And every time you decide to use a brand new, unproven, exciting piece of tech that your team doesn't already know inside and out, you have to spend one of your tokens.
Now, the secret is all in how you spend them. Let's say you're choosing a database. Going with something boring and well understood like PostgreSQL, that costs you 0 tokens. But what about that shiny new vector DB everyone's talking about? Boom, you just spent a token. Running on standard AWS EC2? Boring, 0 tokens. Building out your own Kubernetes cluster from scratch? Oh yeah, that's at least 1 token, maybe more. The danger is, if you spend all your tokens on your infrastructure, you've got nothing left in the tank to actually innovate on your product.
And this whole idea of simplicity brings us to another kind of rebellious idea from David Heinemeier Hansson, the creator of Ruby on Rails. He calls it the majestic monolith. In an age where everyone was screaming microservices, he made the case that for most companies, a single, well-organized code base is actually simpler, faster to work with, and way more productive.
And look, this isn't just some abstract theory. A case study from Amazon Prime Video in 2023 proved this in a huge way. They actually moved a piece of their system away from microservices and back to a monolith architecture. The result? A staggering 90% reduction in their operational costs. It's just a perfect example that sometimes the old way is still the best way.
Okay, so we've seen the high-level view. Now let's zoom in from the architecture to the actual builder's craft, the hands-on principles of writing code that's built to last.
According to the absolute legend Joel Spolsky, this is it. The single biggest, most catastrophic mistake a software company can make is deciding to throw away all their existing code and start over from scratch. The textbook example of this is Netscape. Back in the late 90s, they decided their browser code was a mess and they started a total rewrite. It took them 3 years. And by the time they finally launched, they had lost the entire market to Internet Explorer. Game over.
So why is rewriting from scratch so incredibly dangerous? Well, Spolsky's insight here is just genius. It is way harder to read code than it is to write it. That messy, ugly old code base that you absolutely hate, it's not just code. It's years of accumulated knowledge. It's thousands of tiny bug fixes for weird edge cases that nobody even remembers anymore. When you throw that code in the trash, you're throwing all of that battle-tested wisdom away with.
Okay, another crucial principle in modern code quality is this idea of parse, don't validate. For years, what did we do? We validated input. We'd check if a string looked like a valid email, and if it passed the check, we'd just pass that same string further into our system. The problem? Every single function down the line just has to trust that the check was done correctly. Parsing is a totally different game. It doesn't just check the data. It fundamentally transforms it into a brand new structured type, like a dedicated email object.
And here is where the magic happens. By parsing your data right at the edge of your system, you make it literally impossible for invalid data to even exist inside the core of your application. The compiler itself becomes your security guard. You've just eliminated entire classes of bugs by design. You've made illegal states totally unrepresentable. It's a game changer.
But great software isn't just about elegant architecture or squeaky clean code. And that brings us to our final section, the professional's mindset.
This is all about understanding that we build software for people, and we do it within the context of a business. And a perfect tool for this is another classic from Joel Spolsky, the Joel test. It's a dead simple 12-question checklist from all the way back in the year 2000, and it's designed to quickly get a sense of how mature a software team is. Now you might be thinking, 2000, that's ancient. But trust me, the principles are as relevant as ever.
Let's just see how it translates to today. Question number 1. Do you use source control? Back in 2000, that probably meant some clunky system like CVS. Today, of course, it means Git, and it's completely non-negotiable. Or how about question 3? Do you make daily builds? Back then, that meant running a script every night. Today, that exact same principle has evolved into what we call continuous integration, or CI, where we build and test our code on every single commit. The tools are different, but the core discipline is exactly the same.
This leads us to what is, I think, a truly career-defining piece of advice from Patrick McKenzie. He argues that you should stop defining yourself by the thing you do, writing code, and start defining yourself by the value you create. Your company honestly doesn't care about your beautiful, elegant algorithm. They care about what it achieves. Does it make money, or does it save money?
This highlights a really critical shift in mindset. A programmer sees messy code and their first instinct is, ugh, I have to rewrite this. But a professional engineer looks at that same messy code and asks a different question. What is the return on investment of rewriting this compared to building that new feature our customers are begging for? It's a fundamental move away from technical purity and toward business value.
And focusing on value absolutely means focusing on quality. So many people think quality is the opposite of speed, but data going back as far as 1996 shows it's the other way around. Look at this. A bug you find during the design phase is super cheap to fix. But that same bug, if it's found by a customer out in the wild, it can cost 100, even 1,000 times more to fix. This proves a vital point. The fastest way to build software is to prevent defects from ever happening. Real quality is speed.
So after going through all these foundational ideas, from architecture to code to our careers, what's the one big philosophy that ties this all together?
Well, it really just boils down to 3 simple truths. Number 1, complexity is your enemy. Always. Whether that means choosing boring technology or fighting the urge to rewrite everything, the goal is always to reduce complexity. 2, context is king. A monolith isn't always the right answer, and microservices aren't always bad. The right choice always depends on your specific situation. And number 3, software is, at its heart, a human effort. It's about communication, it's about discipline, and it's about creating value for other people.
In the end, what all of this really teaches us is a powerful lesson. The hot new JavaScript framework you're learning today, it's probably going to be obsolete in 5 years. But the principles of simplicity, of quality, and of value, that kind of wisdom, that's forever.